Okay, so today we're going to talking about solving polynomial inequalities by hand, and we'll go through the following example. Alright, so what we've got here is a polynomial inequality, and rather than using the calculator to solve it, we're going to try and solve it by hand. First step is, again, to pass everything to one side through addition and subtraction properties of equality, and we get negative 2x to the third minus 6x squared plus 12x plus 16 is less than or equal to 0. Okay, and then I try, now we must factor this. Using the factor theorem. The root zero, or rational zero test. And synthetic division. Okay, and so I would factor this by saying that the numbers are negative 2 in the denominator and 16 in the numerator, thus giving me things like 2 and 1, and then I've got 2s, 4s, 8s, 16s, 1s in the bottom, or in the numerator. So again, I'll try 1 and negative 1 to start with. Oh, sorry, maybe you didn't see my roots over here. 2, 4, 16, 8, 1, things like that. Okay? So I'll try f of 1, negative 2 times 1 to the third minus 6 times 1 squared plus 12 times 1 plus 16. So I've got 16 plus 12. These are negative. This is not going to equal 0. F of negative 1. Negative 2 times a negative 1 is to the third power minus 6 plus 12. Now it's actually going to be a minus 12 plus 16. What is this equal to? I've got a negative 12 and a negative 16. A difference of 4. This actually looks like it's going to be 0. If that's the case, then my factor is x plus 1, as I used negative 1 there. Alright? And now I divide this out with synthetic division, so I use a positive 1. If I use the method in the book, I carry down a negative 2, a negative 6. Here is a positive 12, and here is a positive 16. I should get a 0 over here. Now I subtract, so I take this and I drop it. Negative 2. 1 times a negative 2 is a negative 2. And then I've got a negative 6 minus a negative 2. So that means it's actually a negative 6 minus a negative 2 is a negative 6 plus 2, or negative 4. I have trouble with these, so I tend to write them down. Then I got 1 times 4, negative 4. 1 times negative 4 is, well, just negative 4. And then I've got a negative, or 12 minus a negative 4 is actually a 16. Then a 1 times 16 is a 16. 16 minus a 16 is a 0. Look at that, it worked. And so, our polynomial, that is slightly factored, is now like this. X plus 1 is a factor, and then a negative 2x squared minus 4x plus 16 is a factor, and this is still less than or equal to 0. So basically I've just taken my polynomial here, used the factor theorem to find, used the rational root test here to search for rational roots. Turns out that 1 happened to be one of them, negative 1. Then, since the factor theorem says that this must be a factor, I write it down as a factor and I divide it out with synthetic division. Like that. Now this, it looks to be like I can factor out a 2 from here, actually. So I'm going to change this to a negative 2x plus 1. Then I get a, I'll factor out a negative 2. Then I'll get x squared plus 2x minus 8. I factored out a common factor of a negative 2 here. A negative 2 here, I'm left with a 2. And a negative 2 here, and I'm left with an 8. This is still greater than or equal to 0. Sorry, less than or equal to 0. So again, I'm trying to factor my polynomial. That's the first step here. It's almost the first step for this entire chapter, is to factor the polynomial. Now this one I can factor here. Factor x squared plus 2x minus 8. X squared plus 2x minus 8. Now I'll just do this the classic way. If x times x is x squared, and a positive 4 and a negative 2. Because an x times a negative 2 is a negative 2x, and an x times a 4 is a positive 4x. If I add these up, I get a positive 2x, which happens to be equal to that. So my factors are x plus 4 and x minus 2. Okay, that would be factoring. And so over here, I get x plus 4 and x minus 2. Here is my polynomial fully factored. Now if the directions were just factor this polynomial, we would stop here. If this were an equality, then I would write down x equals a positive 2 as an answer, x equals a 4 as an answer, negative 4, and x equals negative 1 as an answer. So x equals negative 1, x equals negative 4, and x equals positive 2. If this were an equality right there. But since it's an inequality, I actually have to do one more step, okay? And I'll do that right over here. Since it's an inequality, I have to take this and I put it in what's called a, well, I'm calling it an inequality chart. And so what we do is we write down all of the factors here. So the factors are negative 2. Don't forget to write down any numeric factors as well. X plus 1 is a factor. X plus 4 is a factor. And x minus 2 is a factor. And you make a chart. Okay? Then up here, notice how I wrote down the roots of these factors. These roots I want to write in numerical order. -4, -1, and +2. Like this. Okay, so what I need to do is I need to turn all of this into a factor chart. All right? And then here I'm going to write -infinity. And here I'm going to write +infinity. Now that I've built this factor chart, I ask myself, when is this factor positive and when is it negative? -2 is always negative. So I'm going to write negatives across. Since this +1 comes right there, why did I put my dot here? Let me show you why else. This +4, I'm going to put a dot right there, and this x -2, I'm going to put a dot right there. Okay? And what that is for each one of the factors that you write down, you put a dot where its root is. Put a dot where its root is. Put a dot where its root is. Then on the negative side, you fill in negative signs. On the positive side, you fill in positive signs. Negative, positive, 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 negative, 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 and positive. Here is my factor chart all figured out. Okay? So let me go back and repeat what we've done here. I've factored my polynomial, classic style. Then I've taken all my roots and I've written them down. I've also figured out the solutions here, or the corresponding numbers. Those numbers get written up top here, and then you fill out the factor chart as seen. Remember, numbers go on there, and if a negative number is always negative. X plus 1 is negative over here, but it's positive over here. X plus 4 is negative over here, but positive over here, and so forth. Now, the final step is to count up all of your negatives here. I've got 1, 2, 3, 4 negatives. This means it is, in the end, positive. 4 negatives is a positive. Here, 3 negatives is a negative. Here, 2 negatives and 2 positives is a positive, and 1 negative and 3, this is negative. Okay? So now these words here are going to be key here. So notice over here, my function is, I'm interested in less than or equal to 0. Which of these numbers over here are less than 0? Positive numbers or negative numbers? You should say that negative numbers are less than 0. Negative numbers are less than 0. And so the actual solution to this is any x value that is in this interval right here. This is a interval that produces a negative number. And since I'm interested in numbers that are less than or equal to 0, then negative numbers are the only one. So I will write my solution as like this, solution. I'll recopy the polynomial up here. -2 x to the third negative 2x to the third minus 6x squared plus 12x plus 16 is less than or equal to 0 when, oops, let me zoom back out here. So I'm now creating my solution here. The solution is the polynomial is less than or equal to 0 when x is between negative 4 and negative 1. Or when x is greater than positive 2. Okay? And since there was an equal sign in my question, all of my inequalities in the answer must have equal signs as well. So what we've done with this chart is we found out when these factors produce a negative number. These factors produce a negative number at this interval. They produce a negative number at this interval. And why are we interested in negative numbers? Because we are talking about less than 0. Okay? And so that would be the solution for factoring inequalities by hand. All right? So you begin by factoring. Once you've factored, you build a factor chart. It seems like a lot of work, but when you get going, it's not too bad. Okay, thanks.